Yes, good evening. Good evening, children. Can you hear me? Hello.
Good evening. Yes, sir.
Okay. So in the last class, we were going with the types of relations, right?
Yes, sir.
Yes. Hmm. So we'll discuss that.
So we discussed still reflexive relations.
I didn't get what you are saying, Vita. Can you repeat again?
So we discussed still reflexive relations.
We discussed till reflexive relation. Okay, we'll discuss the remaining things. So reflexive relation, right? One second. Have you revised? So very simple it was. Have you revised, guys?
Yes, sir.
Reflexive relation we did, right?
Yes, sir.
Yeah. So what was the trick for reflexive relation? All double elements must be there and other order pairs can be there. Okay, that was the trick to remember that. Let me just go through what we have discussed. Reflexive relation, yes. Yes. Okay, I'll give a couple of questions now. Let's see whether it is a reflexive relation or not. Relation. Question is, let A is equal to 1, 2, 3 and R be the relation in set A. Okay, and 1, 1, 1, 2, 2, 2. Okay, now R is given that 1, 1, 1, 3. Check whether they are reflexive or not. First one, this is, let's say, R1 and R2. Whether R1 is reflexive or not. Whether the R1 is reflexive or not.
Sir, R1 is reflexive, R2 is not reflexive.
R1 is reflexive.
R2 is not reflexive.
R1. What about
reflexive,
R1?
sir? 1, 1 and 2, 2 both are there.
It is not.
Is not there.
Comma
Both are
3
not
also has to be
reflexive,
there,
sir.
right?
Yes, it is not reflexive. It is not reflexive. Both are not reflexive. Here 3, 3 is missing. Check kar lo. In R1, 3, 3 is missing, beta. For being a reflexive relation, for making, for reflexive relation, what is the condition? Doublets must be there. Okay. So 1, 1, 2, 2, 3, 3, 1, 2. Then it would have been a reflexive relation. Correct? Here 3, 3 is missing, right? In this relation, you don't have 3, 3. So that is the reason That is the reason we are not saying this as a reflexive relation. Getting my point? Now check whether it's identity or not. It is not even identity. Both are not identity. Identity is only doublet should be there. It is not even identity. Not also not an identity. Okay. Getting my point? Yes. So this is what the reflexive relation is all about. Next, we'll talk about symmetric relation. Symmetric relation. Symmetric relation. Tell me, symmetric relation is nothing but beta.
Symmetrical relation, if there's 1, 2, then 2, 2 also should.
Yes.
A comma B is there means B comma is also has to be there in the set.
Very good. Is called a symmetric relation if A comma B belongs to R, then B comma B must belongs to R. Correct? So this is what the symmetric relation is all about. Okay. So definition of the symmetric relation. Let me give an example. For suppose if relation 1 given to you, that 1 comma 2 is there and 2 comma 1 is there, and this is R1. Let me take R2, 1 comma 1, 2 comma 2, 3 comma 3, and 1 comma 2. That's it. Now check whether it is a reflexive or a symmetric relation or not. Check whether it is a symmetric relation or not. The symmetric relation. The second one, look at this here, 1 comma 1. Reverse of 1 comma 1 is 1 comma 1 only. Reverse of 2 comma 2, 2 comma 2 only. Reverse of 3 comma 3, 3 comma 3 only. Reverse of 1 comma 2, 2 comma 1 is not there. So not a symmetric. Correct? Understood my point? Understood? Understood, children? Any doubts? See, beta, if A comma B is belongs to R, then B comma A must be from R. Okay. Adesha, your voice is breaking a lot actually. I can't even hear you what you are speaking. Next, let me write R3. 1 comma 2, 1 comma 1, 3 comma 3, 2 comma 1, 2 comma 2. R4, 1 comma 1, 2 comma 2, that's it. R5, simple this one. Check. R3 is a symmetric relation or not? R3 is a symmetric relation or not?
No, sir.
R3, why not symmetric relation? Beta 1 comma 2, reverse of 1 comma 2 is 2 comma 1 is available here. 1 comma 1 reverse is 1 comma 1, 3 comma 3 reverse is 3 comma 3, 2 comma 2 reverse is 2 comma 2. It is a symmetric relation. Yes, why not, Adesha? It is a symmetric. Check properly. Understood my point? Here 1 comma 2, beta reverse of 1 comma 2 is what? 2 comma 1, correct? You getting my point? Hello?
Yes.
1 comma 1 reverse is what? If you take this as A comma B, B comma A is also 1 comma 1 only. So it is available there. So it is a reflexive relation, so symmetric relation. So 3 comma 3 is there. 3 comma 3 reverse is 3 comma 3. So doublets always passes symmetric relation condition. Understood my point? Varsha, are you here? Hi, Varsha. I think she can't hear me. Varsha, are
Sir,
you here?
yes, sir.
Hi, how are you?
Fine, sir.
Why didn't you join from past couple of classes? You have not been there. Why?
So the last to last class I had joined, but in the last class I had dentist appointment, and
There is a
sir, before last to last class I had exams, and then last to last class I attended, but last class when it was there I had a dentist appointment.
okay, no problem. We started with the relations. So this is a lecture 2 of relations and functions. I think you have done with the relations and functions from your school side. Okay, hope you know what is identity relation, what is reflexive relation, what is symmetric relation. Hope you all know this. What is universal relation, what is empty relation. You might have learned all this. Am I correct?
Yes, sir.
Yes. If at all you want to revise, please do revise one more time. I just gave wonderful notes. You just go through that, you simply will understand that. Okay, please go through that. Or else if you want to go and if you want to go through the recording and watch with the 2x speed, just put it 2x speed. You can watch it fatafat fatafat. Okay, you can watch it in a faster mode. Okay, that is how you can just do that. No problem. Now tell me here, symmetric relation is nothing but what, beta? If in any relation, if a comma is belongs to R, b comma a must be from that R, then it is a symmetric relation. This is a condition for symmetric relation. Okay. Now I just gave you third relation. Check third relation. You have to check each and every individual ordered pair, beta. So 1 comma 2. If I take this as a comma b, then 2 comma 1, 2 comma 1 must be there. 2 comma 1 must be there. Look at this here, b comma a. Yes, 1 comma 2 is there, 2 comma is available. Now this is double ordered pair. Look at this, 1 comma 1, 2 comma 2, 3 comma 3. Doublets always, double elements. I mean 1 comma 1, 2 comma 2, 3 comma 3. Such type of ordered pairs always passes identity, reflexive, and symmetric. Understood my point? So that is why it is a symmetric relation. Next, R4, check R4. R4 whether is a symmetric or not. 1 comma 1, 2 comma 2. Yes, both ordered pairs are satisfying. Yes, symmetric relation. R5, check whether it is a symmetric or not. R5 whether it is a symmetric relation or not. But I am writing what is the meaning of SA? Symmetric relation on set A. I'm writing in a short way, but if you don't understand like that, you simply write like this. It is symmetric relation. Understood?
Yes, sir.
Okay. Yes. Now fifth relation, check. Fifth relation is a not symmetric relation. Sixth one symmetric relation or not? A cross A is nothing but what, beta? A cross A is nothing but it is a basically universal relation. So universal relation is always going to be a symmetric relation. Getting my point? Hello? Understood or not?
Yes, sir.
Yes. So beta, inverse relation. And one more thing here, note, everyone take note. Okay, note I'll give last, no problem. After explaining one more type of relation, I'll give note. But this empty relation is there, right? This empty relation never passes identity, never passes reflexive, never passes symmetric. Okay, which one? Identity. Identity is not, sorry, not identity, empty relation, beta. Empty relation never passes identity, reflexive, and symmetry. Okay. Now universal relation. Universal relation always passes reflexive, symmetric. Check whether identity, it passes identity or not. Whether universal relation passes identity or not. Universal relation is nothing but what? Cartesian product of the given set to you. Okay. Varsha, what is A cross A, beta, here? Can you tell me? Varsha, can you please try to tell me what is Cartesian, I mean A cross A?
Sir, A cross here.
A cross A is nothing but beta. A is 1, 2, 3. And A cross A is nothing but, for suppose this is 1, 2, 3. This is also 1, 2, 3. Cartesian product 1 to 1, 1 to 2, 1 to 3, 2 to 1, 2 to 2, 2 to 3, 3 to 1, 3 to 2, 3 to 3. Writing that, the whole, you will get whole set, right? All ordered pairs.
Yes, sir.
That is Cartesian product. That if any relation is equal to that particular Cartesian product, that becomes a universal relation. That is called as universal relation. Hope you are aware of that. If not, please go and watch lecture 1 regarding. If you do not know the basics of lecture 1, you will not understand lecture 2 in a well manner, please. So I'm asking whether identity relation, universal relation is a identity relation or not. Think, don't remember here, please. Imagine karo. Think. Are you guys here?
Yes, sir.
Yes, sir.
What is that? Very simple question. Identity is a universal relation or not? See, beta, look at this here. This is a universal relation I gave you. Okay. This universal relation is an identity or not? I'm asking. My goodness. Very simple. What is the problem? I'm asking you to think. Very simple question, simple condition as well. Beta, if you do not understand, look at this here. Write A class A. 1, 1, 1, 2, 1, 3. Okay. 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. This is A class A, right? Now, at least tell me now. Whether this is a universal relation. Do you agree with my point? Yes.
Yes, sir.
Whether it is a identity relation or not. Whether it is identity relation or not. Tell me.
Sir, it is.
How come it is? Why, Adesha? Tell me. It is not. Identity is nothing but only
Sir,
doublets should be
but-
there. Only doublets. Other should not be there. You getting my point? See here. 1, 1.
Yes, sir.
2, 2, 3, 3. Only these three people should be there. Why these guys are coming here? If these guys are coming, that can't be an identity. Getting my point? Only.
Yes, sir.
Read the definition. Only identity. Only doublet should be there. That is what an identity. Clear definition I have given. Clear? Yes. Hope
Yes,
you
sir.
got. So, universal relation never can be an identity. Understood? Understood now? So, it
Yes,
can
sir.
be reflexive now. Check. It can be reflexive. Why reflexive? For reflexive, doublet should be there. Look at this here. This.
Doublet should be there.
Yes, doublets are possible. And others also can be there. Look at this. Others can be there. But mandatory condition is what? Doublets must be there. If any one of the doublet is missing, that is not a reflexive again. If any one of the doublets is missing again, that cannot be a reflexive. Understood? For reflexive, doublets mandatory. Along with the doublets, other people can be there. Other ordered pairs can be there. But doublets are mandatory. For identity, only doublets. Only doublets. Look at this here, beta. Let me tell you. 1, 1, 2, 2, 3, 3. This is identity. Only this should be there. Okay. Now tell me whether it's a reflexive or not. Let me write this is an R7, relation 7. Tell me whether if this is identity. Tell me whether it's a reflexive or not. Yes, it is a reflexive. What I told, doublets, look at it, doublets are mandatory, others may be there, may not be there, others are not here, तो क्या फर्क पड़ेगा? समझ रहे हो आप? Understood my point?
Yes, sir.
Yes, so reflexive. Now check whether it's symmetric or not. Yes, all doublets always pass as symmetric. Doublets need not to check, but whenever you have only doublets, need not to check anything. Whenever your doublets always passes symmetricity. 1,1 का उल्टा भी 1,1 होता है, 2,2 reverse also 2,2, 3,2 reverse also 3,3. So it is passes symmetric as per the definition. Because what I told
Sir,
symmetric. Yes.
sir, isn't symmetric A comma B belongs to R, then B comma A belongs
Yes,
to
that
R?
is what the definition. Look at it, sir. If A comma B belongs to R is nothing but then B comma A must be in R. Now here, then here, look at it, sir. A comma B. If I take this as A comma B as 1,1. Then B comma A is what? Still 1,1 only. Both are available in relation, right? So that is 1,1 is satisfying with the symmetric condition. 2,2 also will satisfies. 3,3 also will satisfies. Clear? Understood
Yes,
my
sir.
point? Yes. So doublets is nothing but better doublet or not omelette. Doublet is nothing but ये doublet दोनों एक ही साथ आए थे ना, एक like same elements 1,1, 2,2, 10,10, 20,20. They are doublets. Identity means only doublets must be there. Reflexive means doublets doublets are mandatory. Along with the doublets, others can be there. For example, let me write R8 relation 8, 1,1, 2,2, 3,3, next 1,2. Now check whether it's identity or not. It is not an identity. Why? Because only doublet should be there. Why this guy is coming extra here? Okay, so only doublets are not there. Other than doublets, you have other elements. So it is not an identity. Reflexive is what? Reflexive is, it is reflexive. Why? Because this is mandatory beta. Mandatory. Now this is optional. Other elements can be there, cannot be there, may be there, may not be there. So still reflexive. Symmetric, check kar lo, symmetric or not. Now Varsha, tell me whether it's a symmetric or not.
It is not.
Yes, it is not. Why? Because 1,1 is there, 2,2, 3,3. These all will satisfy. Reverse of these ordered pair also same thing only. But 1,2 reverse is 2,1 is not available in the relation. Getting my point?
Yes, sir.
So that is why it is not a symmetric. Hope you got the point. Hope you got the point. Everyone?
Yes, understood, sir.
Yes. Shall we go for the next question? I mean, next type of relation? Shall we?
Yes, sir.
Sir, why is it not identity
Where?
relation?
This
The
R8?
R8, yes, sir.
R8, beta, look at this here. Why it is not an identity? Very good question. Identity relation definition hota hai, only doublets should be there. Other than doublets, others should not come. Identity is nothing but beta. Identity is a definition is only this type of relations are always identity. Other than this, you are getting this extra. This shouldn't be there, I'm saying. Only doublets should be available there. Only doublets must be there. Getting my point,
Okay,
Varsha?
sir. Yes, sir.
That is identity relation. Reflexive is what? Doublets must be there. That is mandatory. Other than doublets, others may be there, may not be there. Others means other ordered pairs. Understood my point?
Yes, sir.
Symmetric is nothing but A comma B is there means B comma A must be there. That is symmetric. This is what the relation we learned. Okay. Now think karo. I gave one note. What is the relation between reflexive and identity? What is the relation between reflexive and identity and reflexive?
A comma A belongs to R.
A comma A belongs to R. What is that? Yes, A comma A belongs to they are.
Sir, for identity matrices, actually the every element of that set is related to itself only. But for reflexive relation, that doublet belongs to that relation.
Yes, मैंने
Sir,
relation पूछा हूँ, आपने पूरा definition बता रहा है अध्यक्षा. हाँ, you're telling me full up. Now I'm asking relation, beta. Look at this here. What is the
the
relation?
reflexive can be identity, but identity is always reflexive, but reflexive is not always identity.
That makes the point. That is very beautiful. That makes the point. That is very good relation. That is what I was expecting answer from you. Relation between. I gave a note. No, none of you have revised. Identity and reflexive. What is the relation, beta? Identity relation is always reflexive relation. Okay, but reflexive relation may or may not be an identity. Understood? Isn't it? Getting my point? What is example? I taught in the last class. Same set, beta. What set I'm taking? Set same only. 1, 2, 3. On this set only I'm writing a relation. Let A is equal to 1, 2, 3. 1, 1, 2, 2, 3, 3. Okay. This is the relation, beta. Now look at it here. This is an identity or not? This is identity. What is the meaning of IA, beta? Don't get confused. Sir is writing something IA. IA is nothing but I'm writing in a short way. It is an identity relation on a set A. That is the meaning of that. Okay. It is an identity or not? Yes, it is. Now whether it's a reflexive or not? Yes, it is. Okay. Getting my point? And now let me write. Now check kar lo. It is a reflexive, but not an identity. Understood my point? That is why I'm telling you, beta. Now it is a reflexive. I can say this is a reflexive. Reflexive can be. You say where is that? This identity, beta. Because identity relation is always reflexive. Why? Why? Tell me. Why? Because for reflexive, mandatory condition is what? That must be an identity first of all. Others may be there, may not be there. Now look at this here. This is a mandatory case. Now others. So mandatory only doublets are there, but this guy is coming extra. That is the reason why we are not saying that as an identity. That is why it is not an identity, beta. Other extra ordered pair is coming. Okay, that is a relation. Identity is always reflexive, but not reflexive relation. May not be an identity. Understood my point? If only doublets there, then reflexive can be an identity. Other than doublets, if you have anything so, that can't be an identity. Hope you got the point. Getting my point? Shall we go for the next type of relation?
Yes, sir.
Next, transitive relation, beta. One very, very important. See, if you do not listen this properly, you will not understand. Transitive relation. Are you listening the class?
Yes, sir.
Listen, everyone must listen the class properly. This kind of tricky, comparatively symmetric identity and reflexive. It is kind of tricky, but easy only. Well, I'll make you to understand in a very simplest manner. Look at this here. A relation on set A. Any set you take 1, 2, 3 for making simple is transitive if A comma B belongs to R and B comma C belongs to R, then A comma C
A
must
comma
be,
C should belongs to R.
yes, A comma B and B comma C. Then A comma C, the first and last must be in that R. If not, that is not going to be transitive. This is the word transitive. This is transitive relation. Now, if you write if here A comma B belongs to R and B comma C belongs to R and A comma C is not belongs to R, that is not transitive. Understood? Any doubt, guys?
Sir, I have a doubt.
Yes.
Sir, in our school, like while solving the questions, they said that if there is like any type of situation which you give that A comma B belongs to R and B comma C belongs to R, if it is not given also, that relation is by default transitive. How, sir?
You do not worry. I'll give you multiple examples. You will understand. I'm sure your doubt will be clarified very soon. Within 5 minutes, your doubt will be clarifying if I give an example. Do not worry. I'll come to that point only. Okay.
Yes, sir.
We'll solve an example. Okay. First, suppose, let me give an example. Beta, look at it here. Let's solve a question now. Let set A is equal to 1 comma 2 comma 3. I'm taking this. Okay, I'm writing one relation. R1 is equal, I'm writing as 1 comma 2, 2 comma 3 and 1 comma 3. Yes. Now check low. This is A comma B. If I take this as A comma B, and now A comma B is 1 comma 2. B is what here 2, right? Then B comma C is what? This should be B comma C. This can't be B comma C, correct?
Yes, sir.
Understood my point? This must be B comma C. This can't be B comma C. Why? Why? Because B is 2 here. Then B must be 2 only here. B can't be 1, right? Understood my point? That is the reason. B comma C is. Now A comma C must be there. As per the relation, A is 1 here and C is what 3 here. Dekho, A comma C is available here. So it is a transitive relation. Yes. Understood my point? Understood? Let me write one more relation. Now you have to think a lot here. Now 1 comma 2 and you take anything, beta, no problem. 2 comma 1, let's say 1 comma 1. Check whether it's a transitive or not. Check whether it's a transitive or not.
Sir, here it will not be transitive, right?
Why?
Because here we take A and B as 1 and 2. So we take this as when it's 2 comma 1, it's B comma A. And then you're having A comma A at the end and not C. That's not different.
Sir, but every time B's value will not, C value will not be different, right? Somewhere it will be same, no, sir. It is transitive, according to me.
Then it is not. Then it's not transitive, right? It's
No. Yes, I couldn't get your explanation, Anjali. Look at it here. A comma B, B comma A. From where B comma A we are getting as per the definition? A comma B, B comma C we have learned.
Yes, sir. But like here we took 1 as A, right? A we took as 1, B we took as 2. Now in the second one, 1 is still there. So 1 we're taking as A is confirmed. So we can't change that to C, right? Yes. A and C cannot be 1, right?
Yes. Now, now I understood your point. You, for this type of questions, you would you will be getting confused if you take in that way. For this type of question, what you have to do is, beta, you have to take 2 cases and check. Okay. Now let me take this as A comma B. Then B comma C is what? This must be B comma C. Then A comma C is what? Yes sir, A comma C तो 1 comma 1 हो जाएगा, तो ये तो A comma C है यहाँ पे. A comma C is available clearly. A comma C is clearly available, sir.
Yes, sir, we can take like that, but normally we take A as 1, right? So we can't replace it.
1 second, I'll tell you. Yes, I understood your point. Yes, this is a transitive. Okay, this is a transitive. But actual answer is this is not a transitive. If you say that's a transitive, that is wrong. How come it is possible? You have to check both the cases, right? Look at this here. Now, this is a case 1 beta, okay? Or else let me write let me write first of all 1 comma 2. Okay, this is a comma b beta. Okay, this is a comma b, then b comma c is what? It must be 2 comma 1. Oh, I should write and here. Okay, then 1 comma 1 is what? A comma c. Yes, it is satisfying with the transitive. Okay, this is case 1. Okay, now case 2. Sir, why you're taking this as a comma b? Why can't I take this as a comma b? Check kar lo. Understood my point? Why can't be the second ordered pair as a comma b? What is wrong with that? It is also having a freedom to become as a comma b, right? Who told that I cannot become as a comma b? Yes, you can take 2 comma 1 also and a comma b. Then b comma c should be what? It should start with either this or this. Isn't it? But getting my point? Hello, look at this beta here. B comma c should be what now? B comma c. B is what here? 1 beta. So it can be 1 comma 2 or 1 comma 1. कोई गलत नहीं है यहाँ पे. Isn't it? Anything is correct. Understood my point, Anjali? Now,
Yes,
then
sir.
what is A comma C now? A comma C is what? 2 comma 2. What is A comma C here? 2 comma 1. Yes. Yes, A comma C is, look at it here. 2 comma 1 is there and 2 comma 1 is there. But 2 comma 2 is not 2 comma 2 is not given there. So this case is failing to satisfy transitive. So if any one of the case gets fail to satisfy the transitive condition, the whole relation is not going to be transitive. Understood my point? Clear? Sir, case 1 is satisfying, so I'll go with the transitive. Yes, aisa nahi hoga. You can't say like that. Beta, here I can take 2 comma 1 is also A comma B. Nothing wrong with that. You beta, in set elements or not matters. Look at it. If you have 1 2 3, इसको ऐसा भी लिख लो 3 2 1. कौन मारेगा आपको? समझ रहे हो? एक ही बात है बेटा. You can write like this 2 3 1. ऑर्डर नहीं मैटर करता सेट में, कैसा भी लिखना चाहिए. देखो, अंडरस्टूड माय पॉइंट. इन सेट ऑर्डर इज नॉट मैटर्स एट ऑल. You can write, you can jumble the elements and write. Now look at this is one element here, this is one element here, this 3 ordered pairs, 3 elements. 3 ordered pairs are like 3 elements, so I can jumble the ordered pairs here and there. So if I took A comma B as 1 comma 2, my A comma C was 1 comma 1, that was satisfying. But if I take 2 comma 1 as A comma B, my B comma C chances are what? 1 comma 2 and 1 comma 1. If I take this and this, I'm getting what? I'm getting what? A comma C is 2 comma 2, which is not available. So case in this case beta, here I'm getting fail to prove that as a transitive. So the whole relation is going to be not transitive. Understood?
Yes, sir.
Any doubts? Anjali, you understood now?
Yes, sir.
Shall I give one more question?
Sir, I have another doubt.
Yes, please. Tell me.
Sir, are all reflexive relations symmetric?
Do you want me to check them as well? Yes, we'll check. We'll check whether it is an identity or not. Identity, not possible. Reflexive, not at all possible. Identity is, it is not an identity. How come it is possible? Reflexive, it is not reflexive. Other than doublets, you do have other elements. So identity is not possible. Reflexive also not possible. Symmetric check kar lo. Yes, it is symmetric. Tell me why is it symmetric? If I take this as a comma b, b comma a is available here. Now if I take this as a comma b, b comma a is also 1 comma b, 1 comma 1 only, correct? So it is symmetric. Understood my point?
So my doubt is that are all reflexive relations symmetric?
All reflexive relations? No, 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 no. Need not to be. Why? How come it is possible? Need not to be. Maybe, may not be. Look at this here, beta. Maybe, may not be. All reflexive relations are not symmetric, beta. All identity are reflexive, but not all reflexive are no symmetric. Understood? Varsha.
So
May-
1 comma 1, 2 comma 2, and 3 comma 3 we took as
Yes.
symmetric.
Look at this here. Let me write relation. Tell me your doubt. Tell me the relation. 1 comma 1.
2 comma 2 and 3 comma 3 we had taken as reflexive and symmetric also.
Yes. That is what I'm telling you. Maybe, may not be. I'm not saying that can't be. Try to understand my language. See, beta, it is identity. It is reflexive. It is symmetric also. Why? I'm telling you, doublets always passes. Listen to me, doublets. Look at this. Doublets always. Only doublet means that always passes identity, reflexive, and symmetric. Sir, why it is like that? Why it is like that? If you are not understanding, for identity, only doublets should be there. Yes, only doublets I have. So satisfied. For reflexive, first of all, doublet should be there. Others may be there, may not be there. So yes, only doublets I have. Others are not there. Other order pairs are not there. So problem kya hai? What is the problem? Nothing wrong with that. So still it is a reflexive. Symmetric is what? If a comma b is there, b comma a must be there. So if I take this as a comma b, b comma a is also 1 comma 1 only. If I take this as a comma b, b comma a is also 2 comma 2 only. If I take this as a comma b, b comma a is also 3 comma 3 only. So this is symmetric. Now your doubt is, sir, it is a reflexive. That is why is it a symmetric? No, need not to be like that. Now let me tell you 1 second. 1 comma 1, 2 comma 1, and 1 comma 2. Check. Now whether it's an identity or not. Varsha, tell me.
No, sir.
No. Reflexive.
Yes.
Reflexive, sir. How come it? అక్కడ డబ్లెట్స్ లేవు కదా, అది ఎట్లా చెప్తావు నువ్వు?
Sir, I don't know Telugu.
Oh, you don't know Telugu. Acha, sorry. No, you don't have doublets over there, right? Doublets are not available, right, beta? Doublets, I'm taking on a set here, beta. Look at this here. I'm writing the relation on this set actually. 1, 2, 3. Okay. Now doublets are not available here. Only 1 comma 1 is there. 2 comma 2 is absent. 3 comma 3 is absent. For reflexive, mandatory condition is what? What is the mandatory condition? First of all, the given relation must be an identity. Getting my point? It is not an identity. It is not an identity. So I don't have doublets here. Okay.
Sir,
It
only
can't be.
1 comma 1 is not enough.
No. Identity is nothing but every element must pair with that itself only. Only ordered pairs. Only doublet should be there.
For
Not 1 comma.
reflexive?
That for reflexive only I'm telling you.
Okay, sir.
Let me confirm you one more time. Only doublets. Only doublets. Only doublets is nothing but all doublets, not one doublets. Understand my point?
Yes, sir.
Every doublets, not all doublets. Okay, all doublets should be there. Not 1 or 2 doublets. Sir, मेरे पास तो एक ही doublet है, तो मैंने कह सकता हूँ क्या उसको identity? नहीं कह सकते हम लोग ऐसा. We can't call it as an identity. There must be all doublets. 2 comma 2 भी must be there. 3 comma 3 must be there. अगर एक ना एक 2 comma 2 या 3 comma 3 कुछ ना कुछ नहीं है वहां पे, तो हम लोग नहीं बोल सकते हैं उसको एज आइडेंटिटी. समझ रहे हो आप?
Yes, sir. And same for reflexive also.
सेम फॉर रिफ्लेक्सिव. रिफ्लेक्सिव कंडीशन क्या है? देखो, समझो मेरी बात. पहली उधर डबलेट होनी चाहिए, इधर डबलेट ही नहीं है तो रिफ्लेक्सिव नहीं होगा 100%. ऑल डबलेट शुड बी देयर. अंडरस्टूड अगेन?
Yes, sir. Understood.
All doublets should be there for reflexive also. Other than doublets, let's say now, other than doublets, for suppose other than doublets you have any other ordered pairs, it can be still reflexive. But mandatory is what is mandatory? That is what I told. Look at this here, मैंने बताया था यहाँ पे, कहाँ पे देखो, this is mandatory. देखो बेटा, this is reflexive I said, ये mandatory होनी चाहिए, ठीक है, mandatory. This is what optional. All doublets should be there, must be there. वो mandatory condition है, किसके लिए? reflexive के लिए. Other हो भी सकता है, हो नहीं भी सकता है. समझ रहे हो आप?
Yes, sir.
Hope you got a clarity now.
Yes, sir. I got it.
Perfect. Sure.
Yes, sir.
Sure. पक्का?
Yes, sir.
Yes. Now transitive relation मैंने बता रहा था कहाँ पे? Yes. Transitive understood, right?
Yes, sir.
Yes. I'll give few more examples. But transitive में like many of you will get confused with the transitive. I'll give different questions so that you will find out whether it's a transitive or not. Yes. Now Adesha, you asked one doubt, beta. I'll solve on that. Now check kar lo. Now whether it is a transitive or not. First of all, let us write identity or not, then reflexive or not, symmetric or not, transitive or not. Check whether it is identity or not. First of all, let me.
No, sir, it is not an identity.
It is not an identity. Clear. Soft दिख रहे हैं यहाँ पे.
Not reflexive.
Not reflexive. Doublets not available. Unset I am writing beta.
Not symmetric.
Unset only I am writing. Not symmetric as well. Not symmetric as well. 1, 2 is available, but 2, 1 is absent. Transitive के बारे में क्या बताएंगे आप लोग? बताओ.
But it is transitive.
But it is transitive. Very good. Why? Beta, transitive. What exactly the definition of transitive was? The definition of transitive was if A comma B belongs to R and B comma C belongs to R, then A comma C must be in R. समझ रहे हो आप? Or you can do like you can write in like this as well. If X comma Y belongs to R and Y comma Z belongs to R, then X comma Z must be in R. Anything like I just changed the variables. Anything is correct. Definition लिखने का तरीका एक ही है बेटा. मैं change variable. That's it. हाँ. Now इधर देखो. If I take this as A comma B बेटा, B comma C I don't even have. Understood? Then need not to check. Always it is going to be transitive in that cases. Understood? Are you getting my point? Here A comma B is 1, 2 beta. B comma C is what? Sir, B comma C should be 2, something. But none of the ordered pairs are available, which is starting with the 2. तो मैंने कहाँ से check करूँ? तो possible ही नहीं है यहाँ पे. तो transitive is always. It is going to be always transitive. समझ रहे हो आप? Understood beta? Clear? Anjali, Varsha, any doubts?
Yes, sir.
Whenever you don't have B comma C,
No doubts,
you
sir.
will not check further. You will not check further. Now let me write one more relation. So B comma C is not available. I will not be checking this. Okay. Yes. Next, I'll give one more relation. 1, 1. You take 1, 2 and 3, 3. Check कर लो. Let me erase this definition. Okay. Now tell me whether it is a check कर लो whether it is an identity or not. Identity or not? Varsha, you must give the answer.
Not identity, sir.
Not identity, of course. Reflexive?
No.
Not a reflexive, of course. No doublets available. Symmetric?
No, sir.
Symmetric can't be 1, 2, but 2, 1 is not there. Okay. Sir, I'm having it out here. Beta, if I take this as A comma B, 1, 2, then B comma A is what? 2, 1. It must be there. It is not available there. Okay. Yes. Now if I take this as A comma B, B comma A is what? 3, 3 only. 3, 3 satisfies with the symmetric condition, but 1, 2 is not satisfying, right? Why? 2, 1 is absent. That is why it is not a symmetric. Transitive check कर लो अभी. Tell me transitive.
Sir, it is transitive.
It is transitive. Why? Look at it. If I take this as A comma B, B comma C should be what? Something 2 comma something. But 2 comma something I don't have. I will not be checking further. So for this it is satisfying. Next ordered pair is what? 3, 3. अरे यार 3, 3 तो doublet है. Doublet always passes transitivity again. Beta, I'm telling again and again, doublets always passes identity, reflexive, symmetric and transitivity. Doublets जब भी है उसको नहीं चेक करेंगे हम लोग. Other than that, we'll be taking A, B. I'll never take this A, B. Why? अरे यार हमको साफ साफ पता है वो हमेशा satisfy करता है, तो क्यों लेंगे उसको टाइम वेस्ट करने के लिए? समझ रहे हो आप? सो डबलेट्स को हम लोग कभी भी नहीं लेंगे एज A, B. वी विल नेवर टेक डबलेट्स एज A, B या B, से कुछ भी नहीं लेंगे, उसको छोड़ देंगे ऐसा. वही वी विल जस्ट consider by default, yes, that always passes identity, reflexive and symmetric and transitivity. Other than doublets, you have anything like this, you will take that as A, B. A, B. But B, C is what? It is 1, 2. B, C 2, something. But 2, something never, it's not available in a given relation. So it is always symmetric. Sorry, what is it? Transitive. Understood? Clear, beta? Hope you got the point. Shall I give one more question?
Yes, sir.
1, 1. 2, 1. 3, 3. 1, 2. And 2, 3. Now check. Check whether this is a identity or not. Check whether it's identity or not.
No, sir.
It is not an identity. Other doublets, look at this 2, 2. Yes, better double. Other than doublets, you have extra elements, so you can't say identity. Reflexive?
No, sir.
It is not reflexive. Why? Because all doublets are not available.
2, 2 should be there.
Yes, 3, 3 is there, but 2, 2 is not there. So it is not reflexive. Symmetric?
No, sir, not symmetric also, because for the 2, 3, 3, 2 is not there.
Yes, 2, 3 is there, but 3, 2 is missing there. So it is not a symmetric again. Transitive check kar lo. Transitive check kar lo. Make it fast. Better look at this here. I'll give a trick here. So for transitive, we will be avoiding doublets, I said. Other than doublets, you will take other things. We will not be taking as A, B. Doublets don't take as A, B.
Sir, it is transitive, sir.
It is not transitive. How come it is possible?
Sir, 2, 1 is there, then again 1, 2 is there.
But 2,
Oh, 2, 2 is not there, not transitive, sir.
Dekho, look at this here. I'll not be taking this as A, B, okay? This as A, B. Then B, C should be what? This one. Okay. Then A, C is what? 1, 2, 2. It is not available. So we will not be checking any other cases. If the one case is getting failed, अगर ये केस पे फेल हो रहे हो तो दूसरा केसेस चेक करने का जरूरत नहीं है. समझ रहे हो आप? नीड नॉट इवन टू चेक अदर केसेस इफ यू आर गेटिंग फेल विथ वन केस. सीधा सीधा हम लोग लिख देंगे नॉट ट्रांसिटिव. नॉट ट्रांसिटिव. गेटिंग माय पॉइंट? Straight away we'll go and write that it is not transitive if you are getting given a single case fail. Okay, next let me read one more relation. 1, 1, 2, 2, 1, 3, 3, 1. check कर लो. Make it fast.
Sir, it is not an identity matrix.
मैट्रिक्स कहाँ से आ गया?
Sorry, identity relation, sir, and it is not reflexive also,
Yes. Identity,
but it is symmetric.
symmetric. Okay, doublets always passes. Don't check them. Okay, if I take this as a comma b, yes, b comma a is available. Yes, symmetric possible. Transitive, check kar lo. Make it fast.
Sir, if we take 1 comma 3 as A comma B
Hmm.
and then B comma C as 3 comma 1, then 1 comma 1 is A comma C.
Hmm. A comma c is what? 1
It is
comma 1.
transitive.
One
Yes,
comma.
transitive. But if you take this as a comma b, check karo. That case is possible or not. You have to check that also. You can't decide immediately. Understood?
Yes.
हाँ.
No, sir,
Yes.
it's not possible.
No, sir, not possible.
Yes. देखो मैंने cases बता cases. I'll write the cases and show it to you. If a comma, देखो बेटा, this is my a comma b, correct? Then b comma c is what? It can be 3 comma 1, isn't it? 3 comma 1. So 1 comma 1 is what? A comma c. A comma c. Okay, this is one possibility. Or else you write a comma b is what? 1 comma 3, right? And this is case 1. Now case 2, if I take 3 comma 1 as a comma b and b comma c is going to be what? 1 comma 3 something. 1 second guys, let me charge my lappy. Yes. This is b comma c, right? Then a comma c is what? 3 comma 3, which is not available. So it is not a transitive. Understood? Sir, we are passing with this condition, we are failing here, right? Then why can't you say it is a transitive? Beta, I told that even you get fail with a single case, the whole relation is going to be not transitive. समझो मेरी बात. Clear? Any doubts? Any doubts, Mohammed?
Sir, in R4, transitive.
Which one?
In R4, how is it transitive?
How it is transitive? That is what I was saying. Beta, here if I take this as a comma b, okay, b comma c should be what? Something 2 comma something, right?
Yes, sir.
हमारे पास है नहीं तो कहां से चेक करेंगे? We don't have available with 2 comma something. Then we will not check. We will not check. We will straight away write. We'll straight away decide that yes, 1 comma 2 satisfies with the transitive condition. Then this you take this as a comma b. Then b comma c something. It should be something 3 comma something, right? But 3 comma b नहीं available है तो कहां से चेक करेंगे? समझ रहे हो आज? हाँ. Or else
Yes, sir.
algebraic we will not consider a doublets as a comma b. Okay, don't consider a comma b as doublet. Understood? Doublet को कभी भी a comma b नहीं मानना चाहिए. वो always by default it satisfies. Even you take it satisfies. But time waste नहीं चाहिए आपको. तो मैंने क्या करूंगा? Doublet I never take it as a comma b. I take only this as a comma b. हाँ मेरे पास b comma c I don't have. So I'll not be checking. In that cases I'll be writing yes it is satisfies transitive. Okay.
Okay, sir.
Next. I'll give one more relation. R7, let's say R7. One comma two, 2 comma 3, 2 comma 1, 3 comma 2, and 2 comma 2. Yes. Tell me. Quick. Not an identity. Reflexive or not?
No, sir.
Not reflexive. Symmetric?
It is, sir.
Symmetric.
Symmetrical. It is.
Transitive?
No, sir.
No, either soft sub. Look at it. If I take this as A comma B, then B comma C. A comma C is what? 1 comma 3. 1 comma 3 is not available. Need not to check further. If any case is getting failed, better need not to check any further. उधर ही stop कर देना चाहिए. ठीक है? Understood my point? If I fail with any condition, beta, I never check further. I straight away say that it is not transitive. In case you pass with the case 1, then you check case 2. But if you are failing with case 1, need not to check further. Clear? Hello?
Yes, sir.
Yes, sir.
Is not available. So I'll not check further any cases. I'll not take this as A comma B. मैंने check नहीं करूँगा अभी. क्यों? Why? Because it has got failed here itself. तो transitive नहीं है. साफ पता चल रहा है वहाँ से. ठीक है? Yes, children. So this is the types of relations, and one more relation we have, which is equivalence relation. We'll discuss in the next class. Equivalence relation का मतलब कुछ नहीं है. अगर any relation, if it is a reflexive, symmetric, transitive, any relation, if it is a reflexive, symmetric, and transitive, then such type of relations are equivalence relations. That's it. Simple definition. We'll discuss in the next class. No problem. Please do revise and come to the class. Again, it will be difficult for me to explain from the scratch. Kindly revise. You understood now? It takes hardly 5 to 10 minutes. Revise before coming to the class. It really helps a lot. It will makes it makes you so confident, and that is why I'm telling you, please do revise and come. Okay. Thank you, children. Goodbye.